Okay, so we are going to pick up where, sorry, I forgot to record it. Thank you, Rusty, for reminding me. So we're picking up here a little bit into starting learning about Python. And I was talking about how everything in Python is an instance, every variable is an instance of some class. So here we have 6, x equals 6, it's an instance of an integer, y is an instance of a float, and the type of s is an instance of a string. Okay? Curiously enough, if I have s is equal to just q, the type of s1 is actually a string. It's a string of length 1. There actually doesn't exist a character in Python, oddly enough. Okay? I guess it doesn't really matter, but characters don't technically exist. They're strings of length 1. Okay? Now, what is the most basic data type to Python is what's called a list. Okay? And the most confusing thing that took me a long time to get comfortable with Python were the different types of what we would otherwise call arrays. Okay, and I've put on D2L a document that talks about the different types of data types. Okay, of course we've got integers and floats and strings, and we kind of already understand what they are. But there's a thing called a list. It's very, very important, extremely common. It's basically the way you have an array. There's also things called tuples. There's things called dictionaries. And those three things are all basic parts of Python. And then we'll talk about the NumPy module, which will have what is technically called an array, which is different from a list. And it will talk about matrices, which are different than everything else. Okay? So we have tuples and dictionaries and lists and arrays and matrices, and they all do pretty much the same thing. They're all different ways of having arrays, but how do they all work, and how are they different, and how do we create them, and how do we index them? And like I said, that's what I found the most confusing about trying to get going with Python. So go and have a look at that document. It's the Python Primmer, okay? And it has a lot of different examples of how to do different things with these different types of what I'll call quote-unquote arrays, although the NumPy one is actually technically called an array and the others are not. Okay? So when I say x is equal to 1, 2, 3, 4, okay? And if we say, what is the type of x? The type of x is a list. It's an instance of the list class. Okay? And a list is basically a cell array in MATLAB. Okay, so a list can every element in a list can be an instance of any class. So I can have the first element of a list be an integer, the second be a string, the third be a string of a different size, etc. So I can say, let's say x is equal to 1, 5.6, the string that, and maybe another number. Okay? And so now still, x is still a list. Okay? And the length of this list, the len function, will return how many elements the list has. That makes sense. Okay? Now, how do we index the list? We use the square brackets to index the list. We can use square brackets to, we use the square brackets to create the list, and we can index it with square brackets as well. Okay? Now, notice right here, MATLAB is a real programming language because its indices start with 0, notice. Okay? X of 1 gives the second element. I'm sorry, what did I say? MATLAB. Wow, sorry. Yes, Python is a real programming language because the indices start with 0, unlike MATLAB. Okay? So x of 0, of course, is the very first one. Okay? Now this would be interesting. I haven't tried this before, but I'm pretty sure that the type of x0, see that's an integer, and the type of x1 is going to be a float. So you can see here how this is technically like a cell array in that the first element has a different data type than the second element. Okay? And obviously the data type of the third element is going to be a string. Okay? So again, we're able to have an array of things that have different data types. And so that's the basic. I mean, having a cell array in MATLAB is a little weird and hard and strange, but in Python, that's the base. That's normal. Everything is basically a cell array. Okay? Now, we can slice indices like we can in MATLAB. Okay? Where we can say not only give me just one of the elements, but I can say give me several of the elements. Okay? So give me 2 through 4. Now, if there's one of my enormous pet peeves with Python, and I have yet to figure out why they did this, but for some reason, when you use the colon operator to slice something, the 2 is start at index 2, and this is end at the 4th element, which is in index 3. I don't know why. Surely they had a good reason, but they really are bending things, making me have to think anytime I use a slice. Yes?
I think it's because it's saying go up to the 4th.
It says go up to, but don't...
to the door, but doesn't go in.
Right. It goes to the door, but doesn't go in. But you're exactly right. That's what they've done. I'm not sure why they've done it that way, because MATLAB doesn't work that way, but Python does. Okay, so how do I get to the last element? So I would do 2 colon 5, or I could do 2 colon nothing. Okay, now in MATLAB you would write end, but if you just put 2 colon, it will go to the end. Okay, now it also has a really cool feature that says count from the end to the left 1. Okay, or count from the end to the left 2. So that's kind of neat. So not only can you go to the end, but you can count from the right hand side or from the end in. That's really nice. That's something that MATLAB does not have. Okay, so that's kind of neat. Unfortunately, you cannot use logical indexing on a list. Now that kind of makes sense, because if I said, x is greater than 5, I mean, what the heck does that mean? I mean, I can say, yeah, that's not greater than 5. Yeah, that is greater than 5. But what the heck does it mean for a string to be greater than 5? That doesn't have any meaning. And because lists can have anything in them, the greater than operator might not be defined for whatever object is in the list. So even if I did y is equal to 1, 2, 3, 4, 5, 6, okay, and said y greater than 4 or whatever, that doesn't work. Even though all of the elements in y, the greater than operator is defined for. You just cannot ask if a list is greater than or less. You cannot create a logical or a Boolean list out of that. So you can't use logical indexing on lists. Okay. Again, the main reason is because it's a cell array and it's not generally used for have a bunch of numbers in there. That's actually what the Numpy array is used for, and we'll get to that sometime soon, hopefully today. Yes, question?
Why did it go to what you designated Kevin when you put -1?
Okay, so I did x to -1. So here's x. So that's 0 element, 1 element, 2 element. That's why we got the 2. 3 element, last element.
Right.
And so the -1 goes 1 to the left from the last one. If I wanted to get the last one, I just leave the colon there to go to the end. Okay? So the -1 counts in 1 from the end, not including the end. Okay? That's really helpful. That's really handy. I like that feature. Okay? Now, just like a list here, like an x, can have a value of it can have an object of anything, it can actually contain objects of lists. So let's say I want to replace me, Kevin, that is 0, 1, 2, 3. I want to replace that, and I'm going to replace that with a list of itself. Okay, so now the index 3 is now overwritten. It's no longer Kevin anymore, but is now a list, 567. Okay? So when I say return for me the third element in the list, it itself is a list. Okay? So I could say W is equal to X3. So W is a list. Okay? And then I could index W. Hey, give me the first one. That's going to be the one in the middle, the 6. Okay? Now, I don't have to store that element in the temporary variable W. I can access the parts of the third element there directly. So, of course, that gives me the third element. Okay? But I can then say, hey, index for me the index 1 in that third element. So I don't have to go first to that temporary variable W if I don't want to. Question?
If you just plot X, what is that going to generate?
If I do plot X?
Well, not plot X.
Or print X.
Print X.
If I do print X,
it
prints the whole thing.
Replace the W with the array or...
No, the W is a different variable. Okay? Okay? So, I mean, I could print W as well. That exists, and that's separate.
But yeah, I just didn't know if you printed out the whole thing, if it replaced the string or the array with the W.
It does not replace the array with the W. Okay? All right. So what I was trying to get to here is that X3 returns that list, but then rather than storing it somewhere, I can index it immediately. Okay? So it kind of looks, I mean, if you're C++, this looks like a second dimension, right? It looks like a two-dimensional array. So in a way, it is kind of like two-dimensional arrays. You know, I could set X to be the first element be an array 1, 2, 3, the next element be 4, 5, 6, and the last element be 7, 8, 9. And that's my favorite matrix that I make in MATLAB. But it's not actually organized like a 2D array or a 2D matrix. It's a list of lists that all happen to have 3 lengths. Okay? So yes, I can index it. Hey, give me the 0th row, second column. Okay? That's going to be the 3. Hey, give me the index 2, that's the third row, give me the middle value, that's the 8. Okay? So I can index it and it looks basically like a 2D array. Okay? But what's different is that I could say, let's make the third one not be 7, 8, and 9, but rather just be 7 and 8. And why didn't it let me do that? Okay, because X of 3 does not exist. I'm thinking in MATLAB. It's 0, 1, 2. The third, there was no third, there's 0, 1, and 2. There is no 3. So now it's, you know, in MATLAB, you can't have a two-dimensional array that has different number of columns in every row. That's not possible in MATLAB. Okay? And so now if I say give me the second element in the third element in the list, it doesn't exist because the third element only has, oh, that's what I meant to do. That does not exist. Okay? Because the second element only has 2 pieces in it. Question?
Yeah, would an array enter in the same format that we did in MATLAB with semicolon separations?
No, you cannot use semicolons to separate. At least I've never seen that to be the case. Let's try it just to confirm, but I don't believe that will work. No. Okay? Because a semicolon in MATLAB says go to the next row, and that has no meaning as a list because a list doesn't have rows and columns. It has elements in the list, and each one of those elements in itself could be an array. Well, not really an array, a list. I need to watch my terminology because these are technically not arrays. An array is something different. Okay, it's defined in NumPy. Okay?
So can you set rows and columns in Python as far as arrays go?
Well, I mean, at this point, you know, it kind of is like that. I mean, we've organized the list as essentially as a 2D array, and I index it kind of like it is a 2D array. So for all intents and purposes, it is a 2D array, but it's not technically organized like that. Okay? And many of the things that we're used to doing to a 2D array or a matrix in MATLAB, you can't do to lists. Okay? I can't say, you know, take y and add y to itself. Oh, it did work. But it did something completely weird. I mean, it did something. It did something, but it's not the same. I mean, the result has 12 things. It's not organized like it was before. I'm not even sure what it did. Yeah, it did. That's what, you're right, it did. It concatenated it. It took all of the things in y and it, yes, yeah, it concatenated them together. That's exactly what it did. And I don't know, let's say, what happens if I do x plus x? So it does the same thing. It basically adds, you know, puts them all in. It doesn't do what we were thinking it does. And actually that concatenating thing, it does the same thing for a string. If I say hello plus world, it will concatenate it. Okay? That's interesting. I knew that that strings would concatenate with the plus symbol, but I didn't realize that lists were that way. So the plus operator is overloaded for a list, but it doesn't do what we're used to it doing in MATLAB. Okay? So it's kind of weird. You know, this list thing is really flexible, has all this new stuff, but in the end, I use more things in the MATLAB. I mean, sorry, in the NumPy module, and we'll show that in just a minute here. Okay, so lists are cool, but I actually use some other things more frequently when we're trying to do math. It's more, it's better to use a different data type. Okay, now there's also a thing called a list. I'm sorry, a tuple. Okay, so we've got lists and we have tuples. Okay, and you create a tuple in basically the same way you do a list, but you use parentheses instead of square brackets. Okay, and basically a tuple is exactly the same thing as a list, except a tuple is constant. You cannot change things in tuples. Okay, now you index them and slice them actually in the same way that you do with a list. It's kind of weird. You use the square brackets to index a thing in a tuple. Okay, but what you can't do is I can't reassign the value of a tuple. Once a tuple is created, it can never be changed. It's constant. It's called immutable. Okay? So a tuple is basically the same thing as a list. The only difference is that you use parentheses instead of square brackets for creating them, but you still index them in the same way with square brackets. But you can't change their values. Okay? So you might see some tuples out there. I personally don't use tuples very much. Okay? But they're there, and you'll see them in some of the built-in functions and stuff. Okay? Also, in one thing I've also put on D2L under the course materials is a link to a reference for lists. And remember, a list is a class, and X in our case is an instance of that class. And interestingly enough, the list class has a whole bunch of member functions. Okay? And they're called methods in Python. I guess they're called methods in Java too, right? Anybody done Java? They're called methods in Java, right? I think. So method is basically the same thing as a member function of what we've been talking about in C++. So there's all sorts of things. You can append things to the end of a list. You can extend things. You can insert. You can remove from a list. That one's kind of cool. I did not mean to click on that. Let me show you that. We can say, let's see, pull this up here. Here's my X. I can say X dot remove the element that is 1, 2, 3 out of X. And now X no longer has that in there. No matter where it was, it would go and search for any elements in X that were 1, 2, 3, and it would take them out. Okay, so you can go and browse through these methods or member functions for lists. You can do all sorts of different things with them, really handy. Okay, so there's a link there that can be useful. Okay. I don't want to go into a ton of detail, but there's one really curious thing in Python, is that when you assign, if say I've got x and I set y equal to x, okay? Of course, y is going to have the values that we're used to it having, okay? But what's interesting is that y and x are not separate copies. When you say y equals x, what it does is it actually sets y to point to the same memory where x is pointing. Okay? So x and y are actually pointing to the same place in memory. They're not separate copies. So when you change something in one of them, it changes the other. So for example, if I say make y1, replace it with the value 5 instead of that 7 and 8, if I now look at x, x's 7 and 8 is different too. Okay? So this is really strange. Okay? So y and x are pointers to the same memory location, because in C++, when you declare a variable, okay, you declare a variable and you say, you know, int I equals 5. Okay, what it does is it creates memory for I, and then it stores the 5 in that memory place. And then if I say int j equals I, it creates a new memory for j, and it copies the value that was in x and puts it in y's place. Now, in Python, variables can immediately change to be a different data type. Right now, y is a list, and now suddenly y is an integer. Okay, so the memory that y had as a list is going to be different than the memory that y has as an integer. And so what's really curious is that whenever the values, when you create a value, it gets a particular memory location. And that value, until it gets destroyed, will always be in its own memory location, no matter what variable is linked to it. So in C++, a variable has a memory location that doesn't change no matter what you put in it. In Python, a value has a memory location no matter what variable is pointing to it. So it's a really weird distinction, and most of the time you don't have to worry, because if I say, you know, y is equal to 6 and x is equal to 6, and then I say y is equal to 8, x still stays 6. Okay? Because y was replaced, you know, y was changed completely. Whatever it was before has been thrown away completely, and now it's 8. Okay? But with lists, it's not the same, because you're only getting rid of one of the elements. Okay? So I don't want to go into this in great detail. I have a lot of examples of it in the Primmer. Okay? But the main thing you need to keep in mind is that if you want to copy something and not be bound by that, not be bound by the x and the y, you know, like here, I changed the y part. Let me do that again. So let me set this to be x, set y equal to x, and then say y1 is equal to 10, y is that, and x is that. Okay, you change y and x changes. If I want to copy x into y without that effect, I actually need to use the copy command. And the copy command is not a basic Python command, but rather in a module called copy. So when I say import copy, it will copy in the stuff, it'll import more commands that have to do with this copy module. And if I want to access things in the copy module, I type the name of the module and then whatever command I want to do. So for example, I can have a deep copy of x. So now x is that and y is that. They're the same things. And now when I make y1 equal to 0, y changes, but x does not. Okay? So if you have things that are not the simple data types are like integers and floats and that sort of thing. If you want to copy a list or an array or a matrix, you need to import copy and do this deep copy to be completely safe. There is a copy command, but it is not quite as deep of a copy, and if you really want to know all the details, you can go and read through my primer, but just to be safe, use the deep copy and then you'll never have any problems. Okay?
So that basically allocates different memory to
Right.
Y. Okay.
When you do deep copy X, that says, okay, Y is not going to point to the same place as X, create new memory and copy over the stuff that is in X into the new memory from Y. Okay, that's exactly right. Okay? So that's kind of interesting. I got bit by that. It took me a while to realize that that was what was going on when I had things and I was changing stuff and suddenly other things were changing. So be aware of that. Okay? There are also these dictionaries that I was talking about. I don't personally find dictionaries very useful. They're in the Primmer if you're curious about them. I don't see them used very much, so I'm not going to emphasize them, but they are out there. And basically what you can do with a dictionary is that it's an array of things, but rather than indexing them with numbers, you can index them with tags or strings. So you can have a name for index 0 instead of a number index 0, which can be neat, but I don't find it all that useful. Okay, so those are the basic things: lists, tuples, and dictionaries. I almost never use dictionaries. I rarely use tuples. Sometimes functions I use return tuples, and I need to understand that. Okay, but mostly I use lists, and mostly I use Numpy arrays. Okay, so if we're going to use Numpy, okay, we need to import Numpy. Yes.
Is there a way to clear all this stuff in MATLAB?
I don't know.
Things, that kind of thing?
I'm not sure. I'll have to look into whether you can clear the workspace. I'm not sure about that, Rusty. There's no command called clear. Let me look into that because I'm not sure. I know when you run, if I run this script, if I hit F5, it will be working in a new workspace. It won't take what was already there. Okay. So for example, if I take this out, I'm almost 100% sure of this, but at least let me do this. If I change this and run that, I'll get an error because X does not exist. So you can see here it says restart. It's restarting by running this script and it clears whatever is there. But I'm not sure, you know, how to clear what's here in the command line. But at least when you run a script, it starts fresh. Okay?
Control
All right.
L.
What's that?
It says Control L according to Google.
Control L, so maybe that would do it.
According to Google.
According to Google, and that may be a different IDE. I'm not sure if that's an idle. But I'll look into that. Okay? All right. So if we want to use stuff that's in Numpy, okay, we need to import it, just like we need to import copy. Now, when we import Numpy, anytime we want to use a Numpy thing, we're going to have to type Numpy period. So what a lot of people do, because they use Numpy so many times, rather than having to write Numpy period all the time, a lot of times they'll do this. They'll say import Numpy as a different name rather than Numpy, and they abbreviate it MP. So rather than typing numpy.array, you can just type np.array. So that's very typical to do this as NP, just so that you don't have to type so many things when you want to access NumPy things. Okay? All right. So, yes?
Can you make that anything you want?
You can make that anything you want. You can make that anything. It doesn't have to be NP. It's just typical to make it smaller, and a lot of code you'll see, it's very common, it's common convention to do it NP just so it stands for NumPy. But it could be anything. Yes?
But you couldn't do NP as NumPy dot?
No. You can't do import MP as something because NP doesn't exist.
NumPy dot as NP. Would you not want to do that?
Oh, no, I don't. I think you still have to always have the period. You always have to put the period. Because otherwise you would do something like in that copy, you would be copy deep copy X. You know, if you had the period in there, and then it would all look like one command. So I'm pretty sure you can't get rid of the period. That always has to be there. Okay? All right. So in NumPy, there is an ND array. Okay? And also in the course materials, I have a link here to the documentation for Numpy arrays. And this array is called an ND array, an n-dimensional array. Basically, this allows you to have multi-dimensional arrays. Okay, like what we're used to, you know, 2-dimensional arrays, 3-dimensional arrays, 4-dimensional arrays. So this is what we're used to, both in terms of MATLAB and C++. A list can look like an array, a 2D array with the double brackets, okay, but it isn't technically one. Okay, so there's the some documentation for that. And so now I can say, make me a NumPy array out of a list. Okay, so this thing is a list. This is the same list that I had before. Okay, and so now X exists, and let me do this. Okay, so Y is a list, and X is an ND array, a NumPy ND array. Okay, and if I look what Y is, and I look at what X is, look at that. Okay, NumPy actually formats it to look like a matrix, like a 2-dimensional array. Okay, and it does not do that with the list. Okay, and I can index my list, give me index row 2 and column 1. That gives me 0, 1, 2, 0, 1. There's the 8. I can actually do the same thing with X. Okay, so at this point they're no different. Okay, what you can also do though is you can index X like a row column. You can index it either way. You can use indexing like a list, or you can index like you're used to doing in MATLAB with row column. Both ways are fine. Okay? Now, what's nice is X plus X gives you what you're expecting in terms of MATLAB. See that? Okay? X times X gives you element-wise multiplication. So let me do this again. There's X, there's the original X. X times X is element-wise multiplication. That's different from MATLAB. If you want element-wise multiplication in MATLAB, you have to do dot times. There is no such thing as dot times in Python. ND arrays are element-wise multiplication. If I wanted to do matrix multiplication, okay, I would need to use the numpy dot command. That gives me matrix multiplication of X and X. Okay, and you'll notice the dot command is something that exists only in NumPy. Okay, and so that I need to precede it by the np dot to access the dot command. Okay. A little annoyingly, cosine is not actually part of basic Python. Okay, there is a math. I could import math to get cosine and sine, but it's also in NumPy. Okay, so I can do np.cosine, and that will give me the cosine of it. And of course, I can do np cosine of x, and that will give me the element-wise cosine of my NumPy 2-dimensional array. Okay? Yes?
Is that by default in radians?
Everything is by default in radians, correct. Other question?
I was gonna say,
I think you need to convert. I'm not sure. I don't think. Does it have cosine D? Numpy does not have cosine D. They did not steal that from MATLAB. Question?
I was going to ask, I'm assuming all the trigonometry sine, cosine, tangent.
All the trig stuff are all in
NP
np dot. Yes, NumPy has all of them. Okay. You can also slice here. I can say, give me row number 2, all of the columns, and that returns a NumPy array. Okay, that gives me that. So you can slice, and the slicing works the same. If I do x2 1:2, that does not give me 2 elements, but rather it starts row 2, 0, 1, 2, starting with the 0 first, going to the second element, which is 8. So it slices in the same way that lists do. That little annoying thing on the end. Okay. Now, in here we can use logical indexing. Okay. And so that will return all of the x's where x is greater than 2. Those are all the x's that are greater than 2. Or if I just do x greater than 2, you can see it is now, false, false, true, true, false, it gives you a Boolean. Okay? And this is something that's interesting, is that the elements that are inside NumPy arrays can have different data types. And this one, by default, it has integers, and it didn't display that it was a special data type. But here, it reminded you that those things are all Booleans. Yes?
I may have missed this, but so you're saying it has to be a 3x3 array?
I'm sorry?
It has to be a 3x3 array?
No, x does not need. X can be any size.
Then you can do it as a MATLAB pull out just the true values in Python?
Yes. I mean, that's what this was. Give me all of the x's for which x is greater than 2. That's logical indexing, just like MATLAB.
Yeah,
Okay? Yes?
Is it possible to get like zeros and ones instead of trues and falses? Or
They are there. If I say, let's say x greater than 2, if I convert that to integers, will that work? No. Let's do this. If I can do mp.array x greater than 2 dtype equals int, I think this will work. There. Okay? So what you need to do is you need to create a new NumPy array that takes this as its input, and I've explicitly said I want its data type to be an integer. Okay?
What would it do if you had characters and if you had like b type equals n?
If I d-type, there are certain data types that NumPy has, and so you can't just say anything here. This has to be one of the specified ones that it has. Okay? And I don't know, you can go in and look at the documentation, but I use int, I use float. I know it has unsigned integers and unsigned 8-bit integers, and it has some of the data types, but it's not just any old, d-type can't just be any old thing. It has to be whatever things are already programmed into the ND array. Okay? So here you can see it's different. These ones are integers, these ones are floating point numbers, but you can see there's a period there to indicate to you that they are floats and not integers. Okay? I don't have time now. We need to stop for now. But there's also np.matrix that I can have a matrix. And one of the main things that's different with a matrix is that when I do multiplication on a matrix, it's by default matrix multiplication. So there's x. I do x times x. It automatically does matrix multiplication. So the multiplication symbol for a matrix is the matrix one. Makes sense. Okay? So go ahead, make sure you get Python installed on your machine. Go through the Primmer. Go read through the Primmer, because there's more details in there than what I've done today. And next time, maybe we'll go over for loops and some if statements and stuff like that, and cement anything here. If you have any questions about in the Primmer, maybe go ahead and start a Udacity course, that for the free online course. The one thing in the Udacity course is that it covers creating new classes. Like we did C++ and we created our own classes with data members and member functions. You can do that in Python. I'm not planning to cover that. Okay, so the stuff in the Udacity course covers how to create classes of your own. You can skip over that or look through it. We're not going to create classes ourselves. We're just going to use the classes that already exist in Python. Okay? All right. We'll see you.